Welcome to today's chemistry lecture. This comprehensive lesson covers the fundamental quantitative aspects of chemical formulas and reaction. We will break down every concept, step, example, and quick check questions found across the textbook. The first main concept is percentage composition by mass, which states that the percentage composition of a compound refers directly to the percentage mass of each element present in that compound. To make this intuitive, think of it as a scale out of 100. The percentage of an element is the exact number of grams of that element present in 100 grams of compound. The general mathematical formula for percentage composition by mass is to calculate the mass present of any element in a compound. We use following a relation which states that percentage of an element is equal to the mass of element in a compound divided by formula mass of the compound into 100. It is useful to determine the purity of a compound and its empirical and molecular formulas. It can be performed by both theoretically and quantitative analysis. Here comes our first guided example. Find out the percentage composition of calcium hydroxide. For the solution, we will see formula mass of CaOH2 is equal to 40 plus 32 plus 2, which is totally equal to 74. By applying the formula which we studied before, percentage of an element is equal to mass of the element in the compound divided by formula mass of the compound multiply 100. For the calcium, we will put our values as 40 divided by 74 into 100, which is equal to 54.05 percentage. Percentage of the oxygen, which is equal to 32 divided by 74 into 100, which is equal to 43% approximately. For the percent of hydrogen, 2 divided by 74 into 100, which is equal to 2.70 percentage. By using the formula, we will find the percentage of every element present in that compound. The composition of all chemical products which are in daily use, such as shampoos, cleaners, soaps, perfumes, and fertilizers, are formed using stoichiometry calculations. Here comes our second example, which states that 8.657 gram of a compound were decomposed into its elements. It gave 5.217 gram of carbon, 0.962 gram of hydrogen, and 2.478 gram of oxygen. Find out the percentage of the composition. In the solution, we will see the formula of percentage of element, which state that mass of element divided by mass of compound multiplied by 100. Now we will put the value of every element one by one to get exact percentage of that element present in that compound. For the percentage of carbon, which is 5.217 gram, divided by a total mass 8.657 gram multiplied by 100, which is equal to 60.26%. Now for the percentage of hydrogen, we will put the value of 0.962 gram divided by total mass 8.657 gram multiplied by 100, which is equal to 11.11%. For the last oxygen, we will put the value of oxygen, which is 2.478 gram divided by 8.6 57 gram multiplied by 100, which is equal to 28.62%. So the 100 gram of the compound under study contains 62 gram of carbon, 11.11 gram of hydrogen and 28.6 gram of oxygen. Here comes our quick check challenge, which states that calculate the percentage of sulfate ion in aluminum sulfate. Let's solve this thoroughly using molar masses. In the first step, we will find the molar mass of aluminum sulfate, in which aluminum is equal to 2 into 27, which is equal to 54 gram per mole. Sulfur is equal to 3 into 32, which is 96 gram per mole. Now oxygen is equal to 12 into 16, which is equal to 192 gram per mole. Totally, collectively, 54 plus 96 plus 192 is equal to 342 gram per mole. In the second step, we will find the molar mass of the 3 sulfate units. Mass of 3 sulfate unit, which is equal to 96 sulfur plus 192 oxygen, totally equal to 288 gram per mole. In the third step, we will calculate the percentage. Percentage of sulfate ions is equal to 288 divided by total mass, which is 342, multiplied by 100, which is approximately equal to 84.21%. Now we will move on our second concept, which is empirical formula, which states that the formula which shows the simplest whole number ratio of atoms present in a compound is called its empirical formula. Let us look at 3 foundational examples. First example is hydrogen peroxide. Its true molecular structure is H2O2, but its empirical formula is simply HO, water. Its molecular formula is H2O, and because its ratio cannot be simplified further, its empirical formula is also H2O. Benzene. Its molecular structure is C6H6, which simplifies down to an empirical formula of CH. Ionic compounds and empirical formulas, which state that all ionic compounds are represented by their empirical formula. These formulas show the simplest ratio present between their constituent ions. The formula for sodium chloride represents the simplest ratio 1:1 between sodium ion and chloride ion. Similarly, the formula of calcium chloride shows a 1:2 present between calcium ions and chloride ions. Everything comes with its limitation. Now we have the limitation of the empirical formula. Any empirical formula does not tell us the actual number of atoms present in that compound. Instead, it only represents the simplest minimum ratio. Because of this limitation, it is entirely possible that some completely different compounds share the exact same empirical formula. For example, both acetylene and benzene share the identical empirical formula CH. And the other example of acetic acid, which is C2H4O2, and glucose C6H12O6, both simplifies down the exact same empirical formula, which is CH2O. Now we will see the step-by-step methodology to calculate empirical formula. To finding an empirical formula requires 5 strict steps. Step 1. Determine the percentage composition of the compound. The second step. Find out the number of moles of each element. This done by dividing the mass of each element, its percentage mass, by its atomic mass. The third step is determine the atomic ratio of each element in the compound. This ratio is found by dividing the number of moles of each individual element by the smallest number of moles obtained in step 2. Step 4 is if the atomic ratio obtained is a simple whole number, it gives the empirical formula directly. Otherwise, multiply this ratio with the subtotal digit to get the whole number ratio. Step 5. Use this whole number ratio as a subscript for the elements to get the final empirical formula. Here comes our first example, which states that the percentage composition of compound shows it to contain 25.26% magnesium and 74.74% chlorine. Find out its empirical formula. Let's see the solution. First of all, we change the percentage of elements into grams. For the magnesium, 25.26% is equal to 25.26 gram, and similarly chlorine is equal to 74.74%, which is equal to 74.74 gram. Now in the second step, the number of moles of each element. Magnesium 25.26 divided by 24, which is equal to 1.05. For the chlorine, 74.74 divided by 35.5, which is equal to 2.10. In the third step, atomic ratio of each element. Magnesium is equal to 1.05 divided by 1.05 is equal to 1, and chlorine 2.10 divided by 1.05, which is equal to 2. The empirical formula of magnesium chloride is magnesium MgCl2. Here comes our second example. The percentage composition of an organic compound by mass is 64.8% carbon, 15.62% hydrogen, and 20.58% oxygen. Find out its empirical formula. Let's see the solution. In first step, we will convert percentage into grams, which is same to the percentage. For example, carbon's percentage is 64.8%, which is equal to 64.8 gram. For the hydrogen, 15.62%, which is equal to 15.62 gram. For the oxygen, 21.58% is equal to 21.558 grams. In the second step, we will find the number of moles of each element, which we will get by dividing its total mass. For the carbon, 64.8 divided by 12, which is equal to 5.4. For the hydrogen, 15.62 divided by 1, which is equal to 15.62. For the oxygen, 21.58 divided by 16, which is equal to 1.35. In the third step, we will find the atomic ratio of each element. For the carbon is equal to 54 divided by 1.35, which is equal to 4. For the hydrogen, 15.62 divided by 1.35, which is equal to 10. For the oxygen is equal to 1.35 divided by 1.35, which is equal to 4. Now we will see, according to their atomic ratio, the empirical formula of the compound is C4H10O. Now we will solve a quick check problem which said that a 0.5 gram sample of a compound contains 0.418 gram of antimony and 0.082 gram of oxygen. What is the empirical formula of the compound? Let's apply our rules step by step. First, we will convert directly to moles. Moles of antimony is equal to 0.418 gram divided by 1 to 1.8 gram per mole, which is approximately equal to 0.0034. Now moles of oxygen is equal to 0.082 gram divided by 16 gram per mole, which is approximately equal to 0.005125 moles. In the third step, apply convert whole numbers. Since the oxygen ratio is 1:5, we multiply both ratios by 2. Before that, we will determine the atomic ratio by dividing by the smallest value, which is 0.00343. For the antimony is equal to 0.00343 divided by 0.00343, which is equal to 1. For the oxygen, 0.005125 divided by 0.00343, which is approximately equal to 1.5. Now we will multiply ratios by 2. For the antimony, 1 multiplied 2 is equal to 2. For the oxygen, 1.5 multiplied 2 is equal to 3. Here comes our third concept, which is molecular formula, which is state that the molecular formula of an element or a compound represents the actual number of atoms present in the molecule of these substance. Let's look at the given example of true chemical formula versus their simplified empirical component. For the water, molecular formula is H2O. Hydrogen peroxide, molecular formula is H2O2. Ethylene, molecular formula is C2H4. For the sulfur, molecular formula is S8. The core mathematical equation. The molecular formula of a compound is calculated by multiplying its empirical formula by a whole number integer represented as n. Means formula is equal to n multiply empirical formula. To find the value of this scaling factor n, we use the mass ratio formula, which is n is equal to molecular mass divided by empirical formula mass. Here comes our first example for molecular formula. Benzene is represented by its empirical formula CH, while its molecular formula mass is 78. Find out its molecular formula. Now we will see the solution. First, empirical formula of benzene is CH. The empirical formula mass of benzene is 12 plus 1, which is equal to 13. Now we will see the molecular mass of benzene, which is equal to 78, whereas the n is equal to 78 divided by 13. Therefore, the molecular formula of benzene is 6 multiply empirical formula. Now we will put our values, which is 6 multiply CH, which representatively give us C6H6. So the molecular formula of benzene comes out to be C6H6. Here is an interesting information, which states that stoichiometry is used to determine the optimal dosage of medication for patients based on the weight, age, and other factors. Here is the second example, which is glucose has an empirical formula CH2O and its molecular mass is 180 gram per mole. What will be its molecular formula? We will see the solution. Empirical formula of glucose is CH2O. Empirical formula mass of glucose is equal to 12 plus 2 plus 16, which is equal to 30. Now the molecular mass of glucose is 180. Now the number n is equal to 180 divided by 30, which is equal to 6. The molecular formula of glucose is C6 multiply CH2O, which is equal to C6H12O6. So the molecular formula of glucose will be C6H12O6. Here comes our third key check problem, which is for yourself to solve this. But for your help and solution of this problem is attached to the lecture.